Hello everyone. For this lesson, we are going to focus on Newton's second law. I will now lead up to how Newton's second law came about, and I also need to emphasize to you, right, that when we study motion in kinematics, we're actually describing motion. There is no explanation as to explain to you how this motion came about. In fact, your explanation lies in Newton's law of motions. So let's begin. Now let's take this scenario for example. You have a mass m, and there are two different forces acting on it. There's a 15 Newton force acting towards the right on m, and a 10 Newton force acting towards the left on m. And hence, we calculate resultant force acting on m as 15 minus 10 equals 5. That's because we take the direction to the right as positive, so hence 10 becomes negative, so 15 minus 10. And the result is 5. And what do you mean by resultant force? Okay, what do you mean by resultant force? Right, resultant force, okay, is a very simple English word, right? It refers to the combined effect of. Right, so in this specific example, it's the combined effect of these two forces together that gives rise to a resultant force. Another way to express resultant force is net force. Some students would prefer to write the word net force, some prefer to write resultant force. I leave it up to you. Both have the same meaning. Again, I'll just leave it up to you. Right, and hence the direction of the resultant force is in the direction towards the right. Because of 15 minus 10, you get 5. And taking direction to the right is positive. Since 5 is positive, that means the direction of the resultant force is towards the right. Now, does it matter where the position on the 15 newtons and the 10 newtons are placed? Right. You just have to make sure they are acting on the mass m. This is one variation. Okay, that will lead to 15 minus 10. That's another variation. And that's another variation. As we studied in chapter 1, force is a vector. And vectors have direction. So when we want to calculate resultant vector, we're just very focused on the direction of the vector. So it doesn't matter whether it's pushing against m or pulling m. Right? We just focus on the direction. I'll lead to another example. This time around, I take the direction to the right as negative. Therefore, the direction to the left will be positive. Okay, so in this case, the resultant force acting on m will be 10 minus 15. Right? Because to the right is negative, so this one becomes negative. And hence, negative. So the result will be minus 5 newtons. You can also say net force acting on m is 10 minus 15 equals minus 5 newtons. Right? And the direction of the resultant force is in the direction to the left. Now, these are the other variations. Alright, again, you focus on the direction of the vector. And this is another variation. And this is another variation that will lead to minus 5 newtons. And this is the, right, this is a last variation. Alright? Now let us consider a scenario where the force acts on an object of mass 4 kilogram and causes it to start moving. Cause it to start moving. That means it's initially stationary. Right? Right. So this means it's initially stationary. Okay? And he said the opposing force also acts on the same object. The resultant force acting on the 4 kilogram equals 20 Newton minus 50 newtons equals 5 newtons. Right, so you know the resultant force on this is 5 newtons. Now, the direction of the resultant force is now 5 newtons to the right. Therefore, the 4 kilogram mass will accelerate to the right, which is in the same direction as the resultant force. Okay, and this leads to Newton's second law of motion. It states that the resultant force on the object is equal to the product of the mass right, equal to the product of the mass and the acceleration, the same direction as the resultant force. And therefore, you get F net equals mass times acceleration. Right? Note is F net. Okay, resultant force. Over the years, students like to write this. Okay? No. Right? It's always a resultant force. There must be at least two forces acting on it. So writing F equals ma is conceptually wrong. Right? So some students prefer to write F2 minus F1 equals ma. So what does it suggest? There's an acceleration. Right? There's an acceleration here. And recall what you learned in kinematics. How do you determine acceleration? You can actually get acceleration from a velocity time graph. Right? A velocity time graph, acceleration from velocity time graph. So describing the motion using velocity time graph, you know that the gradient equals, the acceleration equals gradient of velocity time graph. But under Newton's law, it helps you to explain why the object is moving in the first place. Because the resultant force is greater than zero. That's why there's an acceleration. I say again, the resultant force is greater than zero. That's why there's an acceleration.